Alright, so we are back and we are doing problem 6 to 10 of the 2016 AMC 10B. So, starting on, we are going to do problem 6. So problem 6 is a guess and check problem, not really too difficult. You can automatically eliminate 1 because that would mean S is equal to 100 and that's impossible. So 4 is going to be answer B if you're really good at identifying it. But if you want just proof, just try and guess and check. So obviously the best way you want to minimize the digits of S is if you have this and this equal to 0. And then this is the one you're trying to minimize. So the hundredths digit is the only thing that matters. So that means S must equal 400 if you have this. So then if you have 400, you can easily come up with some cases. So all of these are two different integers, and then you can just add 1, and then one that will work is this. Is this, because this would still give you 1, and this would give you 400. And this completely fits the condition, so it should be B. So now moving on to number 7. This one is a little bit annoying because it's complement and it's just a lot of annoying things. So first of all, it helps to draw it out. 2 acute angles. It's going to be 5x, and try and make this one a little bit shorter. It's going to be 4x. And their complement, which means they add to 90 degrees. The complement of one of these is twice as large as the complement of the other. So that means 4x plus, let's say, complement sub 1 is equal to 90. And 5x plus complement sub 2 is also equal to 90. So given that one of the complements are larger than the other, obviously this one is going to be larger than this complement, and it says it's twice as large, and the reason why is because 4x you need more. You would need to add more of a complement to get to 90, so C sub 1 is larger than C sub 2, so C sub 1 is 2 times C sub 2. So now we just have a system of equations we can solve. And then, yeah, you can, I usually like to eliminate it, so, sorry if that looks like, oh, whatever, this looks like a 3, but it should be a 5, so 5, and then I'm going to turn this into, try and eliminate this, plus 10x and then if you should learn how to do system of equations, you should get 6x is equal to 90 and x should equal 15. And so now looking back up here, these are the two angles and they want the sum of the angles, so 4x plus 5x, which is equal to 4 times 15 is 60, plus 5 times 15 is 75, which is equal to 135 degrees if you want to be exact. But so your answer is C. Alright, so next we're doing problem 8, right down here. So it's asking for the tens digit of this number, and this one's a little bit tougher than the rest in my opinion if you don't have a strong foundation. Well, not a strong foundation, but if you don't have a foundation in number theory, this problem will be significantly tougher in my opinion than the others, but it really isn't that difficult if you're good at identifying patterns, because this one's an obvious pattern question. So it's just asking for the tens digit, so this part is negligible, the 20, and this part is negligible. So we do not care about this. So this simplifies to this. We don't care about that because it says only tens digit, and the tens digit will not be affected by the hundreds digit at all. So we get rid of that. So now I'm going to try to look for a trend or a pattern. So 15 to the power 1 will give you a tens digit of 15, or will give you 15 only going from tens and units digit. So 15 squared should give you 225, or let's just say 25. 15 cubed will give you, I mean, you can just draw this out. It should give you 75, and 15 to the power of 4 should give you 25, and this will just repeat, so we just added dot dot dot. And then yeah, so now that we have 2016, we're going to find what 2016 is congruent to x modulo 2, because it repeats in a pattern of 2. And in my previous 1 to 5, I set out a foundation for modular arithmetic. So if you don't remember, x is just the remainder. So if the remainder is 1, then it's going to be 75, and if x is 0, then you're just going to have 25. So basically 2016 is congruent to 0 modulo 2. So that means, let's scroll over, 15 to the 2016 will give you a tens and units digit of 25. So now 25 minus 17 is equal to 0, 8. So therefore your tens digit is 0, and your answer is A. By the way, you can do this with just remainders and checking out patterns. So you don't need to do modular arithmetic, but it helps a lot for more complex problems. So now move on to, let's say, problem 9. So basically problem 9 is asking for this. Sorry for my terrible graph, but it's going to ask for something that looks like this. I always like to draw out a little graph, and then you can plot these points right here. Have this parabola. I'm bad at drawing parabolas, but now it's asking for an area of a triangle inscribed in this parabola, and essentially it's just asking for this. And then, I don't know, let's choose 2 ambiguous points, and we can let this be B, and let's be C. So it's just asking for BC. So in this case, we know that BC is equal to 2 times the x coordinate, because B2, 0, because this is going to be bisected. These two lengths are equal, and you can't have a negative length for BC. So BC is just 2 times the x coordinate, because B is wherever the x coordinate is. And the height is going to be x squared, because you have y equals x squared, and y is the height. And I guess I should write x is 1/2 base. So now that we have this, we know that x squared times base over 2, which is equal to x, is equal to, where is it, 64. So now we just have x cubed is equal to 64. So now, knowing your cube roots, x should be equal to 4, because 4 times 4 is 16, 16 times 4 is 64. So BC is equal to 2 times 4, which is equal to 8. And you have C. Alright, so now for the final problem, question 10. So, just going to do 10 over here, draw a line. So, a thick piece of wood of uniform density, I don't even know what uniform density is. I believe it's like pretty advanced physics. I don't know. But I don't know what uniform density is in the shape of an equilateral triangle, and it's just a bunch of other information. So, I mean, this problem sounds very confusing and difficult, but if you just think about it, there's only one way you can actually do this problem. And actually there are multiple ways, but the easiest way would be using similar triangles. And especially since they say it's the same thickness, only the area matters. And I'll show you like a better way if you really want to make sure that you have the answer correct. So we have 3, 5. So basically the easiest way is just do 3 over 5 is equal to 12 over x. You have 60 is equal to 3. Oh wait, never mind. You can't use similar triangles. Don't do this. You're going to get it wrong if you use this method. I highly apologize. And I'll just use the method that I used. So, we know that density is equal to mass over volume, because it gives you density, and you have to apply density equals mass over volume. And it's pretty complicated. I don't know why they would want to do something like that, but alright, so you have to know this. I mean, if you kind of guessed that it's just the area and it's the relationship of the area, then I guess you could work it out, but this is a better way to make sure that you do it right. So now that we have they have the same density because they're the same piece of wood, so obviously they're gonna have the same density. So we're going to have x ounces, which is the mass, divided by the volume, which is going to be the area times the thickness, is equal to, what is this? 12 over area. Let's just say area 5, and then area 3 times thick. So we can cancel the thickness out because they're the same thing. You can just multiply the thickness by both sides and you'll get the same thing. So they will not matter at all. So x ounces is equal to 12 ounces over the area 5 and area 3. So we're going to save this for later. And right over here, we're going to find the area of 3. So we know that they're all equilateral triangles with side length 3. Then if you use similar, or not similar, but special right triangles, you have 30 degrees, 60 degrees, and 90 degrees. And then you'd get base times height, which is 3 times 3 root 3 over 2 over 2. So area, or I don't know. So we know that this length is going to be 3 root 3 over 2, and this length is going to be 3 over 2. So the area is equal to 9 root 3 over 4, or you can just do 3 times 3 root 3 over 2, because the base, which is 3, times the height, which is 3 root 3 over 2. So we have 9 root 3 over 2 right here. Wait, no, that's area 5. 9 root 3 over 4. And then right over here, area 5, we can similarly do it, and if you know the formula, then you're just gonna get that. So I'm just saving some space, some time. So of course, these cancel out, the root 3 over 4. So now we have, I'm just gonna squeeze it down here actually. So x over 25 is equal to 12 over 9, which is equal to 4 over 3. So 3x is equal to 100. So x is equal to 33.3. And then you have D is your answer, because x ounces, what is the ounce of the second piece? So you have D. And yeah, that's it. So I'll return back with problems 11 to 13. I've already done problem 14. I don't think I've done 15, but I'll do that as a separate one. That one's pretty simple, but. And then the last one I have to finish is problem 22, 15, and 11 to 13. So stay tuned for that.